All right, welcome to week 10, ESYS 50 for classmates. Week 9, you were able to take the rectifier and build it onto your breadboard with both positive and negative variable outputs and be able to demonstrate what the amounts of minimum and maximum voltages were. What you'll be doing in stages from week 10 on will be to take those components off the board that worked so well, and stage by stage you will be putting them onto your project board, and your project board will look something like this. And a brief discussion as to what it is that we have going on here is this. We happen to have your bridge rectifier mounted on the breadboard. I have screw terminals that will be for the secondary from your transformer. Another secondary from the transformer will go here. These secondaries will go to the sine wave input. This secondary will go to the sine wave input. Your center tap will be here, and the center tap will form the ground on the ground plane of the project board. The capacitors will work much better with the new configuration. The new configuration with these capacitors will allow for dual output. The previous design with a single capacitor, because it was so large, we couldn't really do justice in making this a dual output. But now that we have very effective capacitors with smaller diameters, gives us a lot more board space to work with. So if you recall, on the positive side of your project, you had positive here, and positive went to your, come back here, positive went to both the capacitor, positive input, as well as pin 3 of your 317 voltage regulator. And then this circuit all here is going to be represented right here. From the positive side, this will, under the board, jump over to the positive lead of the electrolytic capacitor. The negative lead will go to ground. We do have the 317 regulator here. It's shown without the heat sink. You will, by the time that the project is completed, be putting on a heat sink that will look something like this. This will help to dissipate the heat because these guys will get rather hot. Your 240 ohm resistors were jumped on the board from one pin of the IC voltage regulator to another pin of the IC voltage regulator, and they were laid out on your board in this fashion, in a lateral fashion. On your project board, there's no need for that. On your project board, these will be mounted in a vertical fashion. So on the LM317, this will be mounted straight up and down, and on the LM337, this will also be mounted vertically straight up and down. The specific pin and hole assignments you will be given in due course. The electrolytic capacitors, 10 microfarads and 10 microfarads, are going to be here for both the positive input and the negative positive output regulator and the negative output regulator. These screw terminals are for These two are for your negative voltage regulator, and one set of screw terminals will be for your pot. Remember that you will be taking the 3-wire pot and making it into a 2-wire pot. I demonstrated this before, where you're jumping from the red wire to the center, and then the 3rd wire goes directly to ground. So we're going to take a 3-wire pot and make it into a 2-wire, like so, and therefore we happen to have both positive and negative for your pot going here. The other screw terminals here are for convenience. If those of you who are choosing to put on a digital display for voltage output, then you would make the connection of your wires to these 2 points right here. So that takes care of the negative voltage regulator. Oh, by the way, the little ceramic capacitor is on this side of your negative filter capacitor. So this will be the ceramic. We'll join it. On the positive side, you happen to have 317, 317 with a associated electrolytic capacitor, and the little ceramic capacitor for this particular guy is right there. It's hiding, happens to be right there on the board. And again, you'll be shown exactly what will solder where, and you'll be given coordinates. It'll be just like a bingo system. So these, the breadboard, just like your breadboard, project board, has A, B, C, D, E, and then F, G, H, I, J, and then rows number one, all the way down to row number 30. So every particular solder point will have a roadmap associated to a particular set of screw terminals or components. The positive output will have these sets of screw terminals, and the screw terminals here will be, one set of screw terminals will be for your potentiometer, and the other screw terminal here will be the output going to your digital display, should you choose to use one. So let me just go around this. We are not going to build this all in one fell swoop. This has to be done in stages. You're going to start with the rectifier, with your transformer, and make sure you've got the appropriate AC waveform coming out of it. And then we will then build the positive side of the voltage regulator and make sure it works on your board. And once that's working on your board properly, then we're going to build the negative side onto your board. So again, this is not a rush job. It is not a race to complete. It is rather a lesson in understanding how the different parts of the power supply comes together. And just wanted to give you a preview of how we're going to transition from this arrangement that you did in week 9 to begin to do this arrangement as we will see this in your finished project. Now, what you're not looking at are all the wires that are going on the underside of the board, and I'll discuss that with you in due course. You just have to make sure you have the necessary components so that we can begin soldering this Thursday. Thanks. We'll see you then. Adios.